Welcome back, everyone. Today, we're digging into something absolutely crucial. We're looking at the suitability of coral reef rehabilitation sites in the coastal waters of Tanjung Siangau, over in the West Bangka Regency. Now, if you're a policymaker, a coastal manager, or maybe a mining investor, understanding the actual science behind post-mining ecosystem recovery is, well, it's a total game changer. We aren't just talking about dumping some concrete into the ocean and hoping for the best. Nope, we're talking about a highly precise, data-driven approach to marine reclamation that actually works.
So, here's our game plan for today. We'll start with the legal and moral obligations, then dive into the site selection criteria, parameter analysis, and the real-world challenges out in the field. After that, we'll wrap up with zoning integration, the community's role, and the long-term benefits for investors. Let's get right into it.
Section 1. Legal and moral obligation. This is really the foundation of all the restoration work we'll be discussing.
All right, let's face the facts here. Offshore tin mining definitely drives the local economy in Bangka Belitung, but it's taking a massive toll on the marine environment. You just can't ignore the degradation. But here's the good news. Law number 3 of 2020 and ESDM regulation number 26 of 2018 draw a hard line. They strictly mandate biodiversity conservation as a core part of post-mining reclamation. And honestly, we need to stop looking at these regulations as just annoying bureaucratic red tape. They are the absolute bedrock of a company's moral responsibility to protect the coastal communities that literally depend on this ocean to survive.
Section 2. Site selection criteria, focusing on the multi-parameter map overlay method.
Putting on our environmental expert hats for a second, how do we guarantee this restoration actually succeeds? Well, it is definitely not a guessing game. Researchers go out and collect hard field data on 10 specific physical and biological parameters. Then, they use this technical process called the multi-parameter map overlay method. Think of it like stacking a bunch of maps on top of each other: depth, water clarity, ocean currents. The final result? The Coral Reef Rehabilitation Suitability Index, or CRSI. It pinpoints the exact coordinates where corals actually have the highest probability of not just surviving, but really thriving.
Moving on to Section 3, Parameter Analysis and the Scoring Matrix. Let's look at the hard science behind the map. So, to get that highly coveted Most Suitable or S1 status, corals need some very specific conditions. For starters, the ideal water depth is between 2 and 7 meters. You gotta let that sunlight pierce through. The water also needs low turbidity, meaning it's totally free of mining sediment. Ocean currents are super important too. They need to be around 0.3 to 0.4 meters per second. That's strong enough to deliver nutrients, but not so aggressive that it sweeps the fragile corals away. Plus, you need a hard substrate, like rocks or dead coral, for them to anchor onto. And arguably the most critical piece of the puzzle, the location absolutely has to align with tourism or conservation zoning plans. We definitely don't want to plant corals just to have them mined again tomorrow, right?
You know what's really fascinating about how these parameters are weighted? Community participation and zoning plans carry the absolute highest weight, a perfect 5. Think about it. You could have the most pristine water depth and perfect ocean currents, but if the local community isn't on board, or if the zoning plans clash, the math says your project is pretty much doomed to fail. This index is brilliant because it perfectly bridges the biological needs of the corals with the socioeconomic reality of the people living there.
When Geographic Information Systems, or GIS, stack all these spatial parameter maps together, layering everything from wave heights to conservation protection levels, it automatically runs an elimination process. The less than ideal spots just get filtered out. And this overlapping data process ultimately leaves us with a specific green zone, a spot that is scientifically validated and incredibly accurate for our coral planting.
Section 4. Real-world field challenges. Time for a quick reality check.
Because look, science on paper can be wildly different from reality under the water. The biggest logistical headache we're looking at here is distance. To fix the degraded area, healthy donor corals have to be sourced from Malang Diang Island. That is a solid 12 kilometers away. Moving living marine organisms across miles of open ocean without stressing them out or outright killing them, that is a massive, massive logistical hurdle. It demands serious planning, specialized gear, and a whole lot of speed.
But despite that grueling distance, the field data tells us we have no choice but to act, and act now. The live hard coral cover in the target areas has plummeted below 50%. In some spots, it's hovering around a terrifying 16%. We've hit a critical point where the ecosystem simply cannot bounce back on its own. With such a huge ratio of dead coral, active human intervention is literally the only way to save this habitat.
Let's jump to Section 5, zoning integration, and the community role. This is about building a collaborative future.
So, how does all this environmental science actually create a golden opportunity for the coastal communities? Well, the ultimate Goldilocks zone found through our map overlay method sits just south of Tanjung Siangau. And beautifully enough, this zone is completely clear of any tin reserves, keeping it safe from future mining conflicts. Even better, it perfectly aligns with the provincial coastal zoning plan, which specifically designates this area for underwater tourism. It's just a flawless marriage of marine ecosystem recovery and national coastal spatial planning.
When we rehabilitate reefs inside this marine tourism zone, we're basically handing the locals the keys to break free from their reliance on the extractive mining industry. Healthy corals mean a massive boom in the local fish population, which translates directly into higher daily incomes for the traditional fishermen of Tanjung Siangau. And by actively empowering these citizens to monitor the health of this post-mining ecosystem, man, they don't just become guardians of the reef, they become the main economic drivers of sustainable marine ecotourism. It's a total win for everyone.
And finally, Section 6, long-term investor benefits. Let's talk about the win-win scenario.
What's the long-term payoff for mining investors? It's huge. By relying on this scientific method, mining permit holders smoothly fulfill their legal duties to the state, while also ensuring their reclamation investments aren't wasted on corals that just won't grow. But beyond that, companies are actively de-risking their long-term social portfolios. Leaving behind a self-sufficient fishing community and a booming marine ecosystem, that is the ultimate proof of highly responsible corporate governance.
As we wrap up this explainer, I want to leave you with one final, crucial question to chew on. Are we just mining the present, or are we truly investing in a sustainable coastal economy for the future? The data out of Tanjung Siangau proves beyond a shadow of a doubt that with precise science and genuine community involvement, we actually have the power to fix the mistakes of the past. Thanks for digging into the data with me today, and keep exploring.